Okay, so today we're going to solve palindrome numbers. So this is the problem. Given an integer x, return true if x is a palindrome and return false otherwise. So example 1, input is x equals 121. This is going to return true because 121, as you read it from left to right, it's going to be 121. And when you read it from right to left, it's also going to be right to 121. So this returns true. Example 2, x equals negative 121 is going to return false because from left to right it reads negative 121, and from right to left it becomes 121 negative. Therefore, it's not a palindrome. Now, example 3 is showing x equals 10. Well, just going back to example 2. So the one thing that we can conclude from this is that all negative numbers are not palindrome, because at the end of the day, they're not going to be the same number when put in reverse. It's going to be put in some shape or form this way. Now, example 3, x equals 10 is going to return false. And the reason for that is when it's read from right to left, it's going to be 0, 1. So also from example 3, an edge case that we are able to deduce is that any number that ends with a 0 is going to be not a palindrome. So if we had 100, 1,000, a million, doesn't matter. Any number that ends with a 0 is not going to be a palindrome. The only exception is that all single digits are palindrome. So 0 all the way to 9 are all palindrome because from left to right, they read the same. Now, the constraint is we're going to get a number, x, that goes as low as negative 2 to the 31 and as high as 2 to the 31 minus 1. Now here, we know we're not going to, all these numbers, we're going to return false because all negative numbers are not palindrome. So what we really are testing afterwards is just these numbers over here. Now, I'm going to give you the brute force approach, and the brute force approach is an inefficient way of doing it. The reason it is an inefficient way of doing it is because of the time complexity and space complexity. So, space x, string x, so this converts to string. This is going to take order n in order to convert in time-wise, time complexity. And this equal sign is also the comparison between the two is going to be order n. And then again, we're converting it. So this is order n, and we're going to reverse it. Reverse the string. So this portion reverses the string. So for example, as put over there in the example 2, if we got negative 121, we'll convert it to a string, and it's going to be negative 121. And that's the first step right here. So order n at this point, because it took 1, 2, 3, 4. So magnitude of 4. And the same thing, let's say we're doing this portion over here. We're going to convert it. And it's going to be negative 121. Convert it. And again, converts to negative 121. Then we reverse it. And it's going to be 1, 2, 1, negative. So as we can see, negative 1, 2, 1 and 1, 2, 1 negative are not the same. But this is what this does. Converts it this way. And this one just simply just converts it into a string. Now let's see the result of this. Okay, so we got a string error. Let's see why we got it. This is the reason why we did get this is because I forgot to put a negative in front of that. Okay, so let's see what we got. Still got a string error. Okay, so you got return string. Oh, it's because I'm using string. It should be just string this way. Good. Okay, so that's the. So as we can see, it returned true as it was supposed to, returns false as it was supposed to, and returned false again as it was supposed to. So now let's see how it compares to the rest. As you can see, it's very fast. It takes 2 milliseconds. It beats 95% of the user here. The only issue here is that we're converting it to string. So it's not going to have the proper space complexity and time complexity. And I'll show you that later, why it's not the most efficient solution, even though it takes 2 milliseconds to solve. Okay, so let's try a different approach. Okay, so the optimized approach is this. So as we mentioned before, if x is less than 0, which basically means any negative number, so any negative number is automatically going to return false. And as mentioned before, the reason for that is just because any negative number when reversed is never going to be a palindrome, as we showed previously. It's going to be 1, 2, 1, negative. So that's not going to work. Another thing that we mentioned too, and the reason we use OR is because the first one that shows up as false or true is going to return false. So another thing that we know is this. If x is divisible, let's say by 10, and that equals 0, then we know in this case, like let's say we got 10, that number, when we do the remainder operator and we divide that by 10, it's going to return 0, because that is the digit that is on the first digit, on the ones place. So based on that, we know that this right here is not a palindrome, because again, the reverse of 10 is 0, 1. So that's how we know. But what we don't want to fall into is that we are given, let's say, 0. Because if we do 0 and we divide it by 10, the remainder, we are going to get 0. And then if we just automatically return false on this one, we will be wrong. Because remember, all single digits, read them from left to right or right to left, are exactly the same. They are a palindrome. So in order to make sure the solution is correct, we need to add an additional constraint. And that constraint is that if x does not equal 0, then now this statement is true. So they both must be true in order for this to return false. So it cannot be 0, but if it has a 0 at the ones digit, then we know that it is not a palindrome. Okay. So now, what we're trying to do now is we're trying to reverse the string. And in order to do that, we're first initializing it to 0. So while x is greater than the reversed half, we're going to do the following. Reversed half equals reversed half times 10 plus x, and then the remainder 10. Now what are we doing here? So what we're doing here is, originally let's say we got 0, and then we're multiplying it times 10. Well, let's start off with, let's say we're trying to do 121, which is x right here. So x is 121. And let's say that reverse, which we already have it, is equal to 0. So what we're going to have going there is 0 times 10 plus x with the remainder operator of 10. When this operation is complete, we know that what we're going to have is, we're going to have 0 for this, because 10 times 0 is 0. And then we also know that now we're going to do the remainder, and x, which in this case is 121, in the first place, or in the ones place, is 1. So we know it's going to have 1. So the final answer on that one is going to be 1. So that's what this is going to return. It's going to return a 1, and reverse half is going to equal 1. So then the next thing we want to do is we want to divide x by 10. When we divide x by 10, what we're pretty much doing is we're starting off with 1, 2, 1, and we're going to end up having 1, 2. So we're going to reduce the size. And when looking at time complexity, this one is going to be two things. One, because we're dividing by 10, we know that the time complexity is going to be logarithmic. So it's going to be way faster than the converting to string, which was O of n. Both logarithmic and time complexity was O of n. This one is logarithmic in regards to conversion, because it's going to be looking through half of the results. And the reason for that is because we're not going to go through all 3 digits. All we're going to do is we're going to remove the first 2. Let's say this one, we're going to remove this one, we're going to remove this one. And because we have a middle one, we're going to ignore that middle one since it has 3. And I'll show you that later. But more of the story is, looking at this right now, it's going to be logarithmic. And the other one, in regards to spacing complexity, is going to be O of 1. And the reason is O of 1 is because memory does not change. We have the memory consistent throughout as we do this. Okay, so this will reduce and this will compare. So if we go through the whole process, this is what we're going to have. So we just completed that one. We started off with x equals 121. And then what we ended up doing was we started off with reverse half equals 0. We multiplied it and it gave us 1. And then when we were done with this, we started off with 1, 2, 1, and then ended up with x now equals 12. So let's do it again. So this loop is going to go through it. So now we have reverse half equals 1. We're going to multiply times 10, which basically means we're going to shift it to the right now. To the left, actually. And then we're going to do again x, and we're going to get the remainder by 10. And that's going to give us, now we got 10 for the right side, the left side. And we're going to do the same thing for here, where we basically take out the 2. So now we're going to get the 2. And that's going to give us 12. So now we have 12 for x. And when we take out the 12, we're going to have, let's say 12. And once we do this equal, what we're going to have is 1. So x is at this point going to equal 1. So now when we check here, is x greater, which we already know here, x equals 1, and reverse half is going to equal 12. So the question here is going to be, is x greater than reverse half? No, x is now less than reverse half because x is 1 and reverse half is 2. So now this will go to the next, where we're going to check and we're going to return the answer. So we're going to return x equals reversed half. And what we know here with the first check is that x does not equal reverse half, and the reason for that is clearly x is 1 and reverse half is 12. But the issue here is that we have 3 numbers. Now, if it was even, they would have equaled each other, but because it's an odd number, or at least an odd magnitude, we're going to have to create another check. And the other check is going to be that if x is equal to reversed half, and now we're going to remove the 2 from here because it's an odd number. And that should give us the right answer. So now that we eliminated the half number, now we're going to know, if we do it again, we're going to do the check again. And here we're going to have does x equals reverse half? And yes, x does equal reverse half. So the answer should be true. 121 is a palindrome. And let's see how this tests out. So again, as I said before, the answer is going to be complexity and time is going to be better. But most likely on LeetCode here, the time is not going to be the best. But overall, this is the better solution. Let's see where I messed up. So I got reverse half, which we already had 0. And let's see what it says. Runtime, global name reversed. So this is reversed. There we go. So I misspelled that. Okay. So let's do it again. Okay. So as you can see, pass case 1, case 2, and case 3. Now let's run it. So as you can see, it's 15 millisecond, which is way slower than the previous one. And it only beats 36%. But again, the only reason that's taking place, even though LeetCode is giving you a better rating, is because the number may not be as big. But if we look at here, we can see that the brute force approach, which is the one I did originally, is O of n. As you can see, is going to take a lot longer as the numbers increase. So on LeetCode, it's showing that it's a faster time complexity, but that's probably because they're not using big numbers. But with the optimized approach, as I said, it's going to be logarithm. It's only going to go halfway through the numbers. So no matter how big you get it, it's never going to be, it's never going to grow in magnitude like the brute force approach. And again, same thing for the brute force approach. The brute force approach, when it came to using memory, it was making a duplicate. By creating a duplicate string, now you're creating O of n, which is you're copying the same length of a string, so you have the same magnitude. So the original memory plus that magnitude added. So therefore, and you're also doing a comparison, which is order n. So because of that, the space complexity is order n. Now, when it comes to the optimized approach, the memory is never changing. All you're doing is you're removing from x, as I showed here. You're removing from x and adding to reverse half. So when it comes to space complexity, it remains the same. So that's the reason this is the most efficient approach, even though LeetCode doesn't show it.